Okay guys, this is Dr. Science. We have one more question here to look at. It says a body weighing 14 Newton in air is partially immersed in water. If the mass of water displaced in the process is 200 grams, calculate the upthrust on the body. We're asked to take the value of G as 10 meters per second squared. Option A is 2 Newton as the value of upthrust force. B is 3 Newton, C 3.5, and D 7 Newton. Like I always say, when you understand, try as much as possible to make a sketch. Most times it helps you to see what is happening, So I was like, okay, here is a support. And there's a body. This is the body hanging from this support. And the weight of this body is 14 Newton. That means when you hang it freely in air, nothing around it, just air, you have it weigh 14 Newton. But when you put it in a container filled with water, okay, because it was partially immersed, that means not all the volume of the object was immersed in water. Part of it was immersed in water. At this moment, this object is not going to weigh 14 Newton again in case you hang this to a spring balance. It's going to weigh less. Why? This unseen force from water that will be pushing up on this body, and that force is called upthrust force. Now what will happen? As soon as you lower this object inside water, some part of water will start to go away. A volume of water will go away so that the object will occupy it. Now imagine this is the volume, this is the displaced water. Okay, this is the displaced water. So the volume of this displaced water, the volume of displaced water must be equal to volume of object immersed. If the whole volume if the whole object is massed, that is the whole volume. If part of the volume is immersed, only that volume immersed will be displaced by water. So if this is volume of water or any fluid, let me say any fluid displaced, must be equal to volume of object you immerse. Okay? Then what formula do you use for upthrust? Upthrust is equal to weight of fluid displaced. That means if you get the mass of the fluid displaced by the immersed object multiplied by acceleration due to gravity, that will give you the value of upthrust. So we are saying this is mass of fluid displaced, the F is a subscript, multiplied by acceleration due to gravity, that will give you the upthrust. And from the question, we are told that mass of fluid, which is now water, was 200 grams. Of course, put it in SI unit, you divide the 200 by 1000, that will become 0.2 kg. In that case, upthrust becomes the mass now 0.2 kg multiplied by acceleration due to gravity 10. The value will be 2 Newton, and that is option A.